Okay, so we'll begin to proceed with another topic. So in this topic, we'll begin to run through with the algorithm. So what is algorithm? It is a step-by-step procedure or a set of rules to follow in order to perform a task or solve a problem. It takes an input, performs operations, and produces an output in computing. Algorithms are used to process data and solve problems efficiently. So, in learning algorithms class, this is a step-by-step procedures in each task, even that you are dealing with in everyday task of your lives. Of course, you're dealing with with algorithms. It is a step-by-step sequence of what things you're doing in everyday life. So we have a specific examples here of algorithm, which is that is actually a making a cup of coffee. So of course you're preparing utensils and ingredients, you're measuring coffee grounds, you're measuring the appropriate amount of coffee for that task. Then after you boil water by heating the water in a kettle or what utensils you do have. Place coffee grounds into the cup. You're adding the measured coffee grounds to your empty cup and pour hot water over the coffee grounds. So you're pouring the boiling water into the cup over the coffee grounds. Then afterwards, let the coffee steep. So let the coffee steep for about 3 to 5 minutes to extract the flavor. Now stir the coffee. You stir the coffee gently with the spoon to also mix the coffee grounds in the water. Then you can add sugar or milk. So you can add for if you want some taste for that one, or you can add milk or any cream. You can stir again if the coffee you can stir the coffee to ensure that everything is well mixed and serve and enjoy. Your coffee is ready to serve. So that's how the representation or the steps for the um making a coffee, making a cup of coffee. So why to learn algorithms? So still the same thing, there is an optimization. Helps improve the efficiency of a problem solving. Since of course by learning algorithms, it could optimize as well the specific task of your system. And versatility, it is versatile. Algorithms are used in a variety of applications from searching, sorting to AI and database management. In each system class or in your GUI project, you can definitely incorporate algorithms because if those data structures, if there's no algorithms that will be incorporated in that one, it will not be efficient. Now that is also essential for problem solving as algorithms provide framework to break down complex problems and solve them systematically. So of course, it will be every task will be divided into specific technique. Actually, it will be a there will be a step by step. Um, it will be there will be a step by step run through for that one. Now let's deal with the characteristic of a good algorithm. There is an input. An algorithm must take an input, which is the data that it processes. And when we say input, those are the input that you were trying to deal with, which is the data itself that you were trying to process. And for the output, that is the desired outcome. That produces an output after performing the required operation. After the output, there is a specific definiteness. Each step of the algorithm must be clear and unambiguous. When we say definiteness, everything is actually defined. So, of course, in each of the implementation, you really need to define what are those specific things that must be discussed with. Now, pertains to finiteness. An algorithm must terminate after a finite number of steps. So you were not you were able to define as well earlier what will be the specific topic, where it will end. So it must terminate in a specific time actually. thereafter, for example, if you're able to run through with an ordering system, so it will actually end after a finite time. So how? So for example, after printing the receipt, their specific program will end, of course, since the operations is already done. Now, um for their effectiveness, the operations in the algorithm should be basic enough to be executed, meaning they can be performed in a reasonable amount of time. So, of course, what are those specific algorithms that you were able to know? Were able to check right there, so that it will be effective, because in every data structure, every system that you do have, there is a specific technique that you can definitely use, because there's a lot of algorithms. Talking to algorithms, that is really wide. So you need to really check what is really effective, if this is applicable, if this is useful in that specific system that you are trying to do. You have to know what is the functionality in each of the cases, class. And the types of algorithm, we have the searching algorithm, sorting algorithm, greedy algorithms, divide and conquer algorithms, dynamic programming, backtracking, and graph algorithms. Those are the algorithms that we will begin to discuss with in the latter part. Because of course, learning those type of algorithms is necessary, since of course, as computer science, as IT, you really need to know what is their specific algorithms and data structures, because without data structures and algorithm, you will not know how to solve this kind of system efficiently. So in each of your classes, each of your courses, um, each of their courses, that is still dealing with algorithms and data structures. Data structures is really so um wide gid katama. Now, pertains to this here, we are also having the algorithm design techniques, which is the brute force. When we say brute force, that is a linear cases. A straightforward approach where every possibility is considered until a solution is found. So, when we say brute force, that is a step by step, actually, that you cannot proceed to the next element without searching the previous element. That's how it works. Brute force is often considered inefficient for large scale problems because it doesn't reduce the search space. It doesn't reduce. Why? Because one step at a time gina siya. And that is um, concerning in a sequential manner, in a brute force manner. So brute force is not efficient in a large scale. So divide and conquer, breaking a problem down into smaller sub-problems and solving them recursively. So when we say, um, excuse me, when we say divide and conquer, we're actually dividing. For example, it could be a merge sort or a quick sort. That we do have a specific array. We're dividing that into two and solving them recursively. Divide and conquer algorithms are often more efficient than brute force algorithm because they can reduce the problem size exponentially. So of course, the space that is allocated in that specific task will be divided as well. So afterwards, dynamic programming. We have in a dynamic programming, it is a different task as well, which breaking them down into simpler subproblems and storing the result, improve efficiency by storing results of subproblems, doing the memoization or tabulation, making it faster than brute force, recursive methods then compute the same subproblems on multiple times. Why is it effective? Because, for example, in a binary trees that you do have, for example, this is a Fibonacci sequence. So this is a Fibonacci 5, for example. This is the Fibonacci 3. This is a Fibonacci 4. Then For example, the Fibonacci 4 will deal with Fibonacci 3, Fibonacci 2, in order for you to get the Fibonacci 4. And Fibonacci 3, you will begin to compute the Fibonacci 2 and Fibonacci 1. So that is actually you're dealing with how many times that you will be going to calculate those specific sequence, for example. So you will be going to calculate how many times the Fibonacci 2 in that specific structure. So why will you do the memoization? Then when we say memoization, we're storing the specific element, I mean answer in that specific um, memory, for example. So this is the answer of Fibonacci to earlier, so we'll just be going to use that in later on, so that it will be effective. So it will be run through. I mean, it will be discussed actually if you'll begin to learn more with algorithms and complexity. We'll begin to deal with that in the future as well. If you will switch shift to CSO, it will be definitely exciting for you as well. Now, greedy algorithm, making the locally optimal choice at each step with the hope of finding the global optimum. This is actually dealing with graph as well. Now, finding the global optimum grid are usually faster and more efficient compared to dynamic programming or exhaustive search programming algorithm because they don't explore every possibilities. So say for example in a graph algorithm. So say for example we are from UNOR. So this is UNOR and this is the Lakson, for example. So by going to Lakson, is this the first step? I mean, is this the shortest path? Is this the shortest path? Or is this the shortest path? Or is this the shortest path? So this is the shortest path here because it is only one. Then going here, there is 3 steps. So this is actually a good or a good technique as well because you will not be going to exhaust every possibilities. Now, for backtracking, it is generally algorithmic technique for finding solution to problems that incrementally build candidates for the solution, and it is a powerful. Um, it is a technique for solving problems that involve searching through all potential solutions while ensuring constraints are satisfied. When we say backtracking, for example, you were able to search here already, then the search, the goal is in here. So you will be going to check in here first, then backtrack, then because this is the dead end, so you will be going to backtrack for you to check the other possibilities. Is this the goal? No, this is you will begin to backtrack, then backtrack again, check and backtrack and check. That's how you will deal until you can find the certain path. That is the algorithm works actually. Those are the breakdown, those are the how does it work for algorithms. So thank you so much, and hopefully that you will that you understand how algorithms work, and we will be going to deal with a separate video with the other topics as well. We'll begin to do it step by step so that you will begin to learn it separately as well. So make sure to put a comment below if you were able to understand this video. Thank you so much, my dear class, and see you in the next video.